Now come to the slip system. That was, I mean, till now we have discussed that was a slip. Okay, so what is slip? What is slip plane and slip directions? Okay, what is slip system? The slip system is just a combination of these two. I mean, the slip plane and slip direction combined together is known as your slip system. Okay, so dislocation do not move with the same degree of ease on all crystallographic plane atoms and in all crystallographic direction. What does it mean? It means there are so many planes. You know, if you talk about this particular cubic simple unit cell, they have many planes and they have many direction as well. But what we are talking about, I mean, all the planes do not have their movement, and all the directions are not are responsible to the movement of your dislocation. So there are some particular plane which are responsible to movement of your dislocation, and similarly there are only few direction in which that particular location or imperfection can move. So that, I mean, if something is special reserved for, you know, a special work, that is your concern. Similar to that, here every plane is not going to take a participate in your slip, and every direction is not going to take a participate in your slip direction. So the plane which is taking the participate in your slip plane, and the direction which is slip plane means the movement of your dislocations. Okay, similar to that, the direction in which the direction, I mean, there are many directions in your simple cubic, you know, in your unit cell, right, in your crystallographic structure, but the direction only which is responsible for your movement of your dislocation, that is known as your slip direction. So slip direction and slip plane combinedly together is known as your slip systems. Okay, so all rest all are not you don't know taking a participate in your slip system. That would be not our concern. The concern is our just only on two things, which is the plane which is responsible to movement of your imperfection or dislocations in the direction in which that particular uh, plane is moving is known as your slip directions. Combined together is known as slip systems. So typically there is peripheral plane, okay, and that plane are specific directions along which the dislocation motion occurs. This plane is called the slip plane. Okay, if the it follows that direction of movement is called the slip directions, and this combination of slip plane and slip direction is known as your slip system. Okay. For the particular crystal system, take the example. This is your cubic, right? This is your cubic unit cell. Okay. So here if we take about the, you know, what is your plane? Okay. So this particular plane is take an example. Which plane? A to D, D to F, and F to A. This particular plane is your slip plane. Okay. And if you need to calculate what the direction, then just keep this particular plane in your cubic system and just two direction. One, it could be like A to D, and second, D to A. So two directions are there in A to D. Two directions similarly come from here as well. A to C, sorry, A to F and F to A. So two comes from here. And if we talk about at the bottom, I mean D to F or F to D. So there are total six plane in this particular arrangement. If we talk about the unit cell or the cubic unit cell, or in this is the particular case of your FCC. FCC means the face-centered cubic structure. So I mean, you could think about, I mean, what the plane that is going to be take the participate in your Phillips plane. So the plane which has the most number of the atoms that comes in that way. Like here, if you touch from A to D, so this A atom is going to take a participate, this D1, and the mid term, the B, which is at the face of your left face of your this cube, that is going to take a participate in this line, right? So that will touch. So mostly dense plane, which is going to responsible for your slip plane. Similar to that, what the direction, if you know how to draw the direction, similarly once you have decided what the plane is going to take the participate, that plane you just keep in that in this way, and you can find out the location, so direction will be similar to that. You have just take the image of this plane here, and two kind of the things could happen: either A to D come or D to A. So two direction are coming from here: A to F or F to A, or F to D or D to F. Okay, so there, I mean, the plane, once you have decided the plane, what the plane is going to responsible for the subsystem, then you would not having a problem to define the directions. That is easy. Okay, so how that the direction would also be the same as, I mean, the mostly dense the direction would be of your slip directions, and obviously that would come if you have already decided the plane. So which plane that is the slip plane? The plane which have the most number of atoms present in their plane. Okay, or you can say in a different way that, I mean, the closed packed atoms is our closed packed plane is going to be responsible for your slip plane. Okay, this is a particular example for the FCC. Keep in mind, this is not for the all. This is for the FCC, face centered. And you know what is the face centered cubic structure? I mean, that is the unit cell is like the cubic, and 1/8 part of a single atom is present at each corner of your cubic cell, and half of your atom is present each of your faces. So there are total four atoms are present in that particular unit cell. Okay, so this is basically, I mean, there is a set of the planes like the one plane means, I mean, how you define the Miller indices, which is very common. I mean, you can take any kind of the sorry, what is as a your origin. Once you define the origin, in this case, if you take the example of this particular one in a slip plane, see the figure A. Okay, so this particular corner has taken as an origin. So now this is your Z plane, this is your X plane, sorry, X axis, this is your Y axis, this is your Z axis. Got it? So keep in mind, whenever you define your plane, your origin must not be on that plane. Okay, as you can see, you have defined this particular A, D, and F as your plane. So the line joining with the A to D, D to F, F to A, that is your slip plane. So when you are defining the plane, your origin must not be on any of that corners. So you must have some other corners that is defining your origin. Okay. And opposite to that, when you are defining your direction, then your origin must be on their particular corners. Okay, so this is a very uh, uh, important thing you must need to keep in your mind.